today's class on special distribution of probability, right? And here we discuss about the characteristic function of Chi-Squre distribution with n degree of freedom, and it is symbolically written as Chi-Squre n variate. We have to find out the characteristic function of Chi-Squre n variate. We first write the definition of characteristic function. Generally, characteristic function is denoted by phi xt, and it is defined as expectation of e to the power I t x, where x is the random variable and it is given that x is chi-square, x is chi-square invariate, and t is real variable, that is belongs to real number. And the definition of expectation we use here, integration minus infinity to infinity e to the power I t x into fx dx. Okay, and fx is the PDF of the random variable x. Now here it is given that x is chi-square n variate. So the PDF is given by, we already here write the PDF of chi-square n variate, which is fx, this is equal to e to the power minus x by 2 into x by 2 to the power n by 2 minus 1 by 2 into gamma n by 2. Okay, n greater than 0. It is discussed in the previous class of this playlist. And we put this value and then we change the range from 0 to infinity, because here the range is x greater than 0. So we get 0 to infinity e to the power I t x into e to the power minus x by 2 to the power n by 2 minus 1 by 2 into gamma n by 2 dx. Right. Now we write all the constant term with respect to x outside the integration, and it is given by 1 by 2 to the power 1, and here 2 to the power n by 2 minus 1. So we get 2 to the power n by 2, and this is gamma n by 2. And this is 0 to infinity. We get x to the power n by 2 minus 1, and we write these two exponential together and getting the result e to the power minus x by 2 plus I t x dx, right? And this is 1 by 2 to the power n by 2 into gamma n by 2, and this is integration 0 to infinity x to the power n by 2 minus 1 into, if we take common here, e to the power minus x by 2 we take common, and we get this is x by 2 into 1 minus 2 I t dx. Now to integrate this, we put here x by 2 into 1 minus 2 I t, this is equal to u, and get the result of dx, this is 2 du by 1 minus 2 I t. Okay, now we put the value of this and value of x, here we get the result, this is 1 by 2 to the power n by 2 into gamma n by 2 into integration 0 to infinity, because if x equal to 0 then u equal to 0, and x equal to infinity then u equal to infinity, right? And putting the value of x here, we get this is 2u by 1 minus 2 I t whole to the power n by 2 minus 1, and this is e to the power minus u, and this is dx, this is 2 du by 1 minus 2 I t, right? And clearly 1 minus 2 I t whole to the power n by 2 minus 1, and this is 1 minus 2 I t whole to the power 1. So we write it outside the integration, and from here we get 2 to the power n by 2 minus 1 and 2 to the power 1, so we get 2 to the power n by 2, and 2 to the power n by 2 cancel out from this and this, we get the result as integration 0 to infinity 2 to the power n by 2 and 2 to the power n by 2 cancel out, and we write first this is 1 by 1 minus 2 it whole to the power n by 2, taking common from here and getting the result as another term is here n by 2 into this is integration 0 to infinity. We write first e to the power minus u and u to the power n by 2 minus 1 du, u to the power n by 2 minus 1 du, right? And clearly this is a gamma integral. We already write here the value or the expression of gamma integral. This is gamma n, this is equal to 0 to infinity e to the power minus x to the power n minus 1 dx. And here it is clear that this value is gamma n by 2, because here is n but in this place here is n by 2. So the integration value is gamma n by 2, and this gamma n by 2 and this gamma n by 2 cancel out. So we get the characteristic function of chi-square n variate is like this. This is 1 by 1 minus 2 it whole to the power n by 2. Okay, so we write here, if we write here the characteristic function is given by 1 minus 2 it whole to the power minus n by 2, and where t belongs to r. This is real variable. Okay, and we get easily the characteristic function of chi-square n variate using gamma integral. Okay, thank you for watching.